Hello and welcome to the module 4 CAMS. So till now we have understood how to draw the CAM profile for the various types of follower. Okay, whether it could be a knife edge, whether it's a flat face follower, or it's a roller follower. Okay. Today we will solve some more numericals that has been appeared in the examination. Okay. So first one. So numerical number 5. Let me read the problem. Construct the profile of a cam rotating clockwise. Least radius of cam is 20 mm. Diameter of the roller follower, which is the follower, 10 mm. Angle of lift 120 degree. Angle of lift is 120 degree with UARM. Angle of fall is again 120 degree with the SHM, with simple harmonic motion. Angle between the lift and fall is 30 degree. Cam speed is 300 rpm. Stroke of follower is 30 mm. The line of stroke of the follower passes through the axis of the camshaft. Determine maximum velocity and acceleration during lift and fall. Okay, so first of all, what kind of a follower it is, or what kind of a cam profile you are supposed to draw? Okay, so it's a roller follower. Okay, how do I know? Because the diameter of the roller follower is given, it is 10 mm. Okay, next thing I have to decide whether it's an inline follower or an offset follower. Okay, so is anything given regarding the offset? No, nothing. Okay, so then I know that it is an inline follower. Alright. Next thing I have to identify the motion of the follower. Okay, what type of motion of the follower it is, whether it is uniform velocity, whether it is simple harmonic motion, whether it is UARN, or whether it is cycloidal. Now, in this case, in this particular problem, what they have mentioned was angle of lift. If you observe, angle of lift is 120 degree with UARM, okay, which follows uniform acceleration retardation motion, whereas the angle of fall is another 120 degree, but that is not the same UARM, but it follows simple harmonic motion. Okay, so this is the difference here. The angle of lift will follow the motion of UARM, and the angle of fall will follow the motion of simple harmonic motion. So in this case, how do we solve the problem? That's what we're gonna see. Okay, so solution is a roller inline follower. You know that. And also from the question we can get these data, right? The stroke of the follower is 30 mm. The angle of rise or angle of lift is the same, is 120 degree. Angle of fall is also 120 degree. It's also given. They have also mentioned that the angle between the lift and the fall is 30 degree, which is nothing but the dwell, okay, or the dwell number 1, which is 30 degree. Now, the next after the angle of fall comes the dwell again. They haven't given in the question, but you can always calculate what is the dwell, because the sum of all the 4 angles should be equal to 360. Okay, so angle of lift 120, dwell 30, and the angle of fall 120 gives you 270. So 360 minus 270 gives me 90 degrees. Okay, so even though they have not given the dwell 2, that is after the fall, what is the dwell, we can always calculate. Okay, in most of the cases they won't give you the last dwell, and student is supposed to calculate. Okay, and then the minimum radius of the cam, or the least radius of the cam, is 20 mm, which is nothing but the base circle radius, right? Okay. So to solve this also, we are first supposed to draw the displacement diagram. Let us see how to draw that. Okay, so here is the displacement diagram. Now, so we know that the stroke is 30 mm. So hence I have drawn the vertical length is equal to 30 mm, and then the complete then the first is a angle of rise or angle of lift, which is 120 degree. Right, then comes the dwell for 30 degrees, then again angle of fall, which is 120 degree, and then again a dwell of 90 degree. Okay, now here the difference this time is we know that the angle of rise will follow UARM. Okay, so that portion I'm supposed to draw it in the UARM method. Okay, if you see this, the sketch, okay, so the for the angle of rise, okay, we can identify the middle line, which is the line number 3, and identify the. And in the UARM fashion, we have identified 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Similarly, angle of fall will follow the simple harmonic motion. Okay. Hence, I am supposed to identify 1 dash, 2 dash, 3 dash by drawing a semicircle, which I have drawn it on the right hand side, and then got the projections towards the vertical lines. Okay, so this is the major, and most of the problems will usually be asked like this, where the angle of rise is one motion of follower, and the angle of fall will be another type of motion of follower. Okay, So again, in this case, the angle of rise will follow uniform acceleration retardation motion. Hence, I have to identify the 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash in the UARM fashion, and the angle of fall, which is simple harmonic motion, will follow the by drawing the semicircle. Okay, so in this case, they have drawn the semicircle on the right hand side. Okay, and divided the circle into 6 equal parts, and from each of the point 1, 2, 3, 4, 5, 6, they have drawn horizontal lines to the vertical lines 1, 2, 3, 4, 5, 6, and hence got the 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Okay, so once you got that, then it's the same, just with the starting from 0 in the angle of rise, draw a smooth curve going through all the point of interest. Okay, and then a straight line, and then again from an angle of fall area also draw a smooth curve, and from the 0 of the angle of fall to the end of the line to get the displacement diagram. Okay, so this is how the displacement diagram is got. Okay, so next step is pretty simple. You already know that. Now to draw the CAM profile. Okay, so to draw the CAM profile, it's a roller follower. We know that. Okay, so in case of a roller follower, there are two circles. Okay, roller inline follower. One is the base circle. Next is the prime circle. Okay, I'm supposed to draw both. So base circle radius is already given 20 mm. So first draw the base circle. It's also mentioned in the sketch, in the diagram. Base circle is a radius 20, and then I have to draw the prime circle. Okay, so the prime circle is nothing but the radius of base circle plus radius of follower. In this case, they have mentioned that the roller follower is diameter 10 mm, hence the radius is 5. Okay, so hence the prime circle radius will be 25 mm. So first draw those two circles. Then, because you know that it is an inline follower, from the center of the CAM, okay, that is O, draw a vertical line to the prime circle to get A. Okay, to get A. Okay, then start identifying the angle of lift, dwell, fall, and then again dwell. Okay, so with OA as keeping the protractor OA, start identifying all the angles, divided into 6 equal parts, and all the 6 equal parts should be marked on the prime circle. Okay, just like how we thought in the last class. Okay, all these 1, 2, 3, 4, 5, 6 should be marked on the prime circle, and then from those points you're supposed to draw the line to the center O, and then keep on extending. Okay, after that, from the displacement diagram, measure the length of 1 dash, 2 dash, 3 dash, 4 dash. Then with center at 1, 2, 3, 4, start drawing the arc. Okay, to get 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Okay, then after getting all these points, then with the radius equal to the radius of the follower, start drawing circles. Okay, from 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. As center, I start drawing the circle with radius equal to 5 mm. Okay, which is the radius of the follower. Once you got that, draw a smooth curve to get the CAM profile. Okay, so if you so you can understand this problem better only when you go and watch the previous videos where how to draw the CAM profile is already shown. Okay, in case of a roller follower. All right. So I hope you understood this problem. Again, practice only once you practice you will get this. Okay. Now in this problem, at the end they have also asked that determine the maximum velocity and acceleration during the rise and the fall, during lift and the fall. Okay. Now for the maximum velocity and acceleration, okay, the formula is given in a chart. All right. Now this chart is already there. I already put up in the CAM notes. Okay, it's already in the Edmodo site. Okay, please download that PDF file. In that, along with your definition of CAM, types of followers, types of CAM, all those things, I have also put up this equation, this chart. Okay, here for each type of motion, if you see, there is simple harmonic motion, UARM, and cycloidal. Okay, for them there is a formula for maximum velocity and maximum acceleration. Okay, so from here we have to see this formula you have to remember, and depending upon the motion of the stroke, you are supposed to give the answer. Okay. Now, if I take the first one, simple harmonic motion. It's a simple harmonic motion. Now, maximum velocity VA is equal to pi omega s by 2 theta A. Okay. Here, pi, you know what pi is. Omega is nothing but the angular velocity, which is given in the bottom. Okay. angular velocity omega is equal to 2 pi n by 60, where n is the speed of the cam, okay, and also s is nothing but the stroke. All right, so this you are supposed to know or memorize. Okay, now in our case, in our problem, okay, n is the speed of the cam, which is given as 300 rpm. Okay, and s is nothing but the stroke length, which is 30 mm. But for substituting, we have to use it in the meters. Okay, hence 30 mm becomes 0.03 meter. Now omega is nothing but the angular velocity, which is given by 2 pi n by 60. In our case, the speed of the cam n is 300. So if I substitute to that formula, I'm going to get omega as 31.4 radian per second. Okay, this is the angular velocity, is radian per second. Okay. Now in our case, the angle of lift, which is 120 degree, follows UARM. Okay, so when I calculate the maximum velocity and maximum acceleration for the lift portion, I have to use the formula which pertains to UARM. Similarly, in this case, the angle of fall will follow the simple harmonic motion. Hence, while calculating the maximum velocity and maximum acceleration, I have to use that formula. Okay, so these formulas I have gotten it from the chart, from the previous chart. Okay, it is not nothing new. Okay, all right. So let us now go to the next. So I'm supposed to calculate the maximum velocity and maximum acceleration for angle of rise, it's nothing but outwards, as well as angle of fall. So for angle of rise, theta r, right? Okay, let's please go here, which follows the UARM motion. Now theta r is equal to 120 degree, right? But I want it in radians, hence 120 into pi by 180 will give me it in radian per, not radian per second, only radians. Okay, only so 2.09 radians. All right. So the maximum velocity v is equal to 2 omega s by theta. How did I get this formula? From the chart. Okay, for UARM, that is the formula for maximum velocity is 2 omega s by theta. So that when I substitute 2 into omega is 31.4 into s is nothing but the stroke length, which is 30 mm or 0.03 meter, divided by theta. Theta is in radians, should be in radians, 2.09. So I'll get it as 0.9 meter per second. Similarly, I have to calculate the maximum acceleration. The formula is 4 omega square s into divided by theta square. So I know what 4 is. 4 into 31.4 whole square it is. It's not 2, it is whole square into 0.03 divided by 2.09 square, which gives me 27 meter per second square. Okay, so here it is omega square, so 31.4 square. It is not 31.42. Okay, that is a mistake there. Then next, I have to calculate the same thing for the inward angle also, or angle of fall, which follows the simple harmonic motion. Now, angle theta f is equal to 120 degree. Again, convert that into radians. How? Into pi by 180 gives me 2.09 radians, not radian per second. Okay, radians. Then maximum velocity is given by, because it's simple harmonic motion, maximum velocity v is pi omega s by 2 theta. That's the formula. So you know what pi is, and into 31.4 is the omega, into 0.03 is the s, divided by 2 theta. So that should be 2 into theta. Okay, again there is a small typo there. It should be 2 into theta, or 2 into 2.09, which gives me, I think, 1.4. Okay, I'm not sure. Okay, otherwise please, I just saw this type of mistake here. Okay, it's actually pi omega s by 2 theta. Okay, so here it should be pi into 31.4 into 0.03 divided by 2 into 2.09. Okay, it should be that. All right, so that will give you some answer. I don't know whether it's 1.4 or something else, so please check that. All right, then the last one is a maximum acceleration is a is equal to pi square omega square s by 2 theta square. Okay, so again here also okay, so pi square, that 31.4 whole square into 0.03 divided by 2 into 2.09 whole square, which will give you 33.41 meters per second. Okay, so I hope you understood this. So in the next problem, we're going to solve for a roller offset follower. Okay, so that will be problem numerical number 6. Okay, let's see you later.